Hi, let's talk about interference. Interference basically is simply when two waves overlap and their amplitudes combined. And they can combine in one of two different ways, constructive interference or destructive interference. Constructive interference is when the amplitudes add together. So if we've got this example, so we got this wave, let's say the amplitude's 1 meter, coming this direction. We have this other wave, again, let's say its amplitude's 1 meter, going the opposite direction. When they perfectly overlap, so this crest matches up to this crest, this trough matches up to that trough, for that brief instant, we get this. We get a wave that has a much higher amplitude. So if both these were 1 meter, this would be a 2 meter tall wave. And so if it was sound, it would be louder. Admittedly, sound is a longitudinal wave that has compressions and rarefactions. But if you graph a longitudinal wave, the compression becomes a crest and the rarefaction becomes a trough. And so it looks like a transverse wave. Destructive interference is when the amplitudes subtract from each other. So in this example, we have this wave going to the right and this wave going to the left. And let's say they perfectly overlap. So this crest matches up to that trough. This trough matches up to that crest. And we have a 1 meter tall crest. And the amplitude for this one's also 1 meter. So that means we got a 1 meter deep trough. So if you got 1 meter tall heel, meets a 1 meter deep valley, they completely fill in and you get nothing. And so that's what noise canceling headphones are trying to do. If this was sound, you would not hear anything. A lot of times it's not that perfect and some sound leaks through where the amplitudes aren't matching perfectly, or maybe the wave pattern's off slightly. But noise canceling headphones try to take the ambient noise from the background, play it back 180 degrees out of phase, so that the two waves will cancel each other out and muffle that background sound. Let's say we've got these two waves heading towards each other. Let's go back up to this top one. And so as they approach each other, eventually this crest will match up to that trough. So again, we have a heel matching up to a valley. And so when that happens, this fills in that one and the sound will get diminished. When crest matches up to crest, you get an even bigger crest. Like if you got a 1 meter tall heel getting put on top of another 1 meter tall heel, you get a 2 meter tall heel. So it will get louder. But as it comes in, at first, this cancels out that. And so we get a crest, a flat spot, then a trough. Then if when they overlap, it gets louder. Then when they go through. So it's alternating constructive and destructive interference. And when that happens, when we play two notes that are just slightly off from each other, you get what's called beats. Beats is that alternating constructive and destructive interference pattern where the frequency are just off slightly. And so, for example, it gets louder, quieter, louder, quieter, louder, quieter, louder, quieter. And so if you hear 10 hertz for the beats, that means the two waves are 10 hertz off from each other. So if we're hearing 10 beats per second, and one wave we know it's 50, the other wave has got to be either 40 hertz or 60 hertz. It's got to be 10 off because we hear 10 beats every second. So I'm going to show you that with a demonstration here in a second. Okay, I've got this tuning fork. It's middle C, which is 256 hertz. So if I play it, it sounds like this. Now notice I touch up here. If I touch here, it doesn't affect the wave, so that's a node. But if I touch an antinode, I kill the wave. And so this one sounds like that. Again, if I touch up here, I kill the wave. Touch down here, that's a node, I don't kill the wave, only when I touch an antinode. Now, if we get two waves passing through each other, we can set up what's called beats. Beats are when we have two waves slightly out of frequency with each other. So I've got this other tuning fork that's got these masses on there, so I can adjust its natural frequency. So this one sounds like this. This one sounds like this. Even I think I can tell the difference. But when I play them together, hear that high, low, high, low, high, low? Those are called beats. That's alternating constructive and destructive interference. So if I get them slightly more off from each other, hear then high, low, high, low, high, low. If you count the number of beats, that's how much off they are from each other. So this is 256. Let's say you were hearing 4 beats. So this one's either got to be 260 or 252. It's got to be 4 off from this one, because we know what this one is. This is 256. And if we were hearing 4 beats per second, so it's either 4 hertz above 256 or 4 hertz below 256. Okay. With those beats, it's alternating constructive and destructive interference. Thank you, and I'll talk to you again on another video.